Hello students, this is Mr. Allen, your geometry teacher. Today we are going to look at section 2.3, biconditional statements. Our objective here today is to write biconditional statements and recognize good definitions. So this lesson is going to lean heavily on what we did in section 2.2, which is on conditional statements. So what is a biconditional statement? Hopefully you know the word or the suffix or prefix, I should say. Bi means two. So a biconditional statement is a single true statement that combines a true conditional and a true converse. So the two things that are required here are a conditional and its converse. Here is an example of a biconditional statement. A triangle is equilateral if and only if it is equiangular. So I'd like to point out that you'll have a good idea if you're dealing with a biconditional statement if you see the words if and only if. So let's see how that actually breaks down. Let's look at an example. It says, what is the converse of the following conditional? If the converse is true, let's write a biconditional. So what I'm going to do is we're going to start off here with a conditional statement, and it is in yellow here, highlighted. If the sum of the measures of two angles is 180, then the two angles are supplementary. Now recall, this first piece is called the hypothesis of this conditional, and then this second part here is called the conclusion. So if we're going to write the converse, we need to take that P and Q and switch their order. So the converse would be, if two angles are supplementary, then the sum of their measures is 180. So now here's the question. What is the truth value of this statement? If two angles are supplementary, is the measure of those angles 180? Well, the answer is yes. So this is true. So we can then write our biconditional. And if you recall in the previous slide, I mentioned there were certain words that are a good indication that you've got a biconditional, and those words are if and only if. So what we're going to do is we're going to take this hypothesis and this conclusion and use the if and only if to connect them. Two angles are supplementary if and only if the sum of their measures of the two angles is 180. So this is a biconditional statement. You'll notice that it has if and only if, and by the way, it doesn't always have to have if and only if. If it does, that helps you see it a lot more easily. But this is just an example that we can create from the true conditional and the true converse. So symbolically, up to this point, we've talked about P arrow Q. We've talked about, negation P, arrow negation Q, which is called the inverse. We've talked about Q arrow P, which is called the converse. And we've even talked about not Q arrow not P, which is known as the contrapositive. Today, we're going to introduce a new symbol. And that new symbol, instead of having a one-sided arrow, it's got a two-sided arrow. So this is the symbol we use when we talk about a conditional statement. So, and we would read that P if and only if Q. So these symbols would be read as P if and only if Q. Example 2, what are two conditional statements that can be formed from this biconditional? So remember, a biconditional statement is made up of a conditional statement and its converse. So here we see those four key words there, if and only if. So we want to break this into a conditional and then its converse. So let's just let this first part be the P and this second part here be the Q. So let's go ahead and write our conditional statement P arrow Q. P implies Q, and that would be if a ray is an angle bisector. That's the first part. That's our hypothesis. Then it divides an angle into two congruent angles. So that's our conclusion. So this is the conditional. Now we want to write the converse of that conditional. So remember, we do the converse, we just need to take the P and the Q, and we're going to switch their order. So in other words, it'd be Q implies P. If a ray divides an angle into two congruent angles, then it is an angle bisector. So these are the two conditional statements that can be written or represented by this biconditional statement. The biconditional statement is comprised of two conditional statements. Here we have explicitly listed them or written them out. So what makes a good definition? Well, a good definition is one that uses clearly understood terms. So if we use terms that we've defined and they're clearly understood, that's nice. It's not going to be a good definition if we use words that no one understands. A good definition is precise. We want it to be precise. We want to be able to differentiate what something is based on its definition versus something that is not based on that definition. And finally, we want the definition to be reversible. Now, reversible, this is kind of where that whole biconditional thing comes in, because if you remember, a biconditional is P arrow Q, which is true, and its converse, Q arrow P, is true. So this is that whole concept of being reversible. So example 3, is this definition of a quadrilateral reversible? If yes, let's write the true biconditional. It says a quadrilateral is a polynomial with 4 sides. Well, we could write a conditional. Again, we could break this into 2 parts. We could say that this is the hypothesis and then this is the conclusion. So we could say a figure is a quadrilateral, then it is a polygon with 4 sides. The converse of that would be, if the figure is a polygon with 4 sides, then it is a quadrilateral. So we've just shown that this is reversible because these 2 statements could represent the statement up above. And since both of these statements are true, and let's just make sure that they are, again, they are, if it's a quadrilateral, then it has 4 sides. That's true. If it has 4 sides and it's a polygon, then it's a quadrilateral. That is also true. So since both of these statements are true, we can write our biconditional statement. Can you guess what 4 words I'm going to make sure I include? So let's see if we can do that. In fact, you might want to stop and write it. Actually, yeah, I'll go ahead and write it, but here's the original statement. A quadrilateral is a polygon with 4 sides. So how could we write that? A polygon is a quadrilateral. And what are those keywords again? If and only if, if and only if, sorry about that, it has 4 sides. A polygon is a quadrilateral if and only if it has 4 sides. So that would be what we would define as a good definition. Instead of saying a quadrilateral is a polygon with 4 sides, a better way to write it might be a polygon is a quadrilateral if and only if it has 4 sides. I think that's going to end our presentation for the day. Take care.